Hey everyone, welcome to Doc Walk, the show where we walk through the docs. I'm your doc walker, Daniel, and in this video we're going to be continuing our series about GraphQL, and in particular start diving into terms and definitions and how they relate to each other. And my general philosophy on learning is that understanding is the triangulation of knowledge. So once our vocabulary is expanded, it will be off to relating concepts to each other, and after that the application of understanding will be in your, or the application for your understanding will be in your hands. So we did a lot of vocabulary in the last video, and we have a little bit more to do in this one as well. Before we jump in, if you haven't already liked the video and subscribed to the channel, I sure would appreciate it, and the YouTube algorithm would as well. And regardless, thank you for spending some time with me today. I appreciate it, and I hope that you find the tutorial enlightening and helpful. So the first concept that we're going to be looking at today is is related to schemas and types, and the first one in particular, well, we're going to look at the latter first, but the first concept that we'll look at is the type system. And by the way, I'm taking inspiration for this content from the official GraphQL docs, so follow along there if you feel so inclined. What we mean by a type system is that the interactions in GraphQL predominantly revolve around selecting fields on objects, right? We talked about databases and tables and querying those in the last one, right? Person name, person age, other attribute, email, so on. And so that's sort of like the mental paradigm you have to be thinking about for GraphQL to make sense at all. Now, the next kind of part of that is the typed language. The quote-unquote language just refers to the syntax of GraphQL, which will be the same whether you're implementing it in JavaScript or any other programming language. From my experience, most of what I've seen is JavaScript, TypeScript, etc. But I wouldn't be surprised if I'm sure that you can do it in other languages, but most of what I've seen is that people are doing it in JavaScript and TypeScript because they're using it in front ends or maybe in a node server. Well, both, but but that's kind of the most common use case. The next topic to kind of go into as a little bit more depth, I would say, is objects, types, and fields. And we kind of talked about fields in the last one, but we'll kind of bring it together with the other ones here. And these are, in my opinion, pretty basic concepts, but worth going through so that you can have a context of what they mean later when we get into the more advanced topics. So an object in GraphQL usually maps to an object in a database, so a person table or a person object in Ruby or another programming language. And a field is one of those attributes of the type, so that's name, age, hair color, so on. And then finally, there are types which signify the format that a field comes in, which could be primitive data types like string or integer, or it could be another type that you define that's a collection of subfields and so on. And for example, age would be an integer, but the hair field might be a hair type, which would have its own attributes like color, which would be a string, and length, which is an integer, or a float if you were getting to millimeters in length, or fractions of a millimeter. And so by structuring data in this way, you can query all the attributes of a person like age and hair length arbitrarily without having to concern yourself where it's stored in the back end. The next term is arguments, and it is essentially what it sounds like, and it's a parameter passed to a query to filter by. Arguments are always named rather than passed in a particular order, so it's more explicit. And and as a result, it's much less prone to errors because you don't have to say oh, did I mean to call name as the first argument and then email as the second one, and then what I mean. it's always an object, and it's always, you say like name is this, email is this, and so on. Now, there are, you can define any kinds of types that you want to and work with them, and it maps to your database as you see fit. But there are, beyond those normal ones, there are two special reserved types that are universal to all GraphQL projects. The first is the query type, which is an aggregation of all the types that you define, and that you define like in the server as an entry point for querying. And the latter is the mutation type, which allows you to make write operations to the backend and database. So you can work with these query and mutation types as if you had defined them, but you don't have to define them because they're implicit. That, I believe, would be valuable for educational purposes, but I don't think that it's not necessarily something that you would take any like active action on as you're developing, for example. So remember a second ago I was talking about primitive data types, and those are called scalar types because they're essentially known as such because they don't have any children types, and that would be things like integer, boolean, string, as opposed to a hair type, which would have child fields. Next up is enumeration types, and these are types where the possible value could be one of any in a range of several different types. And this is helpful where an entity has several different kinds of legitimate values and you want to support that aspect despite the fact that there's a strict typing system in GraphQL. So if hair length, or hair dot length, if the length attribute of hair could be a string, or it could be a float, or it could be an integer, you can essentially like have support for that, even though that technically means that you're like giving length 3 different hair types. That's totally legit. You just have to define it as such. So we're getting close to the end here, and there's just a couple more vocabularies to know. Lists and non-null. These are punctuations that you can use to signify behavior in the graph query in the GQL language. So non-null is noted with a bang or exclamation mark, and it means that the server has to always return a value. Usually an ID is set with an exclamation mark with a bang because generally speaking all tables and objects have a primary key of an ID, and so it should always be safe to query for that. And if there isn't one, you may have run into some mangled data that's worth throwing an exception for. That would be pretty weird if a database table was missing a primary key of some kind. Anyways, I was imagining instances that it might not be, but that's not part of this. So lists are noted in square brackets and tell GQL that the response will be an array of values. So if you said string in square brackets, you'd be telling GQL to expect an array of strings, basically. The instance that I was thinking of above, where you wouldn't have a primary key, is in places like join tables. So, but moving on, we're not talking about that. Anyways, next is interfaces. Interfaces is a little tricky of a concept, but basically what it means is that each of the values in the type being implemented by a second type will be in the first one as well. So to make that less abstract, let's think of that person class that we've been talking about for the past couple of videos. And beyond that, let's think of a cyclist class. Since a cyclist is a person, every instance of cyclist will have the attributes of a person. That's what this term means, essentially. The next one is union types. So since interfaces talked about the fields in common between types, Union types refer to bringing together types whose fields don't necessarily overlap, but which need to be aggregated together nevertheless. The last terminology for this video is input types, and this basically relates to data that you want to write into the backend. If you expect form data to be in such and such a structure, then you'll define a type that lines up with that, and this ensures that predictable data will be packaged up and sent to the backend. All right, so that was a lot, but we made it through. Good job, give yourself a hand. And that's all for this video. I hope you found it helpful and thought-provoking, and helpful and thought-provoking enough to like and subscribe if you haven't already. But that's all for this video, and thanks so much for spending some time with me today, and I'll see you all in the next one.